Hello children, how are you all? Welcome to one more new session. My name is Naresh, welcome to our channel Physics Plaza. Children, in a previous session, we discussed about energy, there especially we discussed about mechanical energy. There we had studied what is a kinetic energy and types of kinetic energy. Then we studied what is a potential energy and types of potential energy. Children, what is kinetic energy? The energy possessed by a body by virtue of its motion is called kinetic energy. And then we study the types of kinetic energy: translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. Then we studied the relation between kinetic energy and linear momentum. What is linear momentum, children? So it is like, the quantity of motion contained in a body. We can call it as actual linear momentum, but mathematically we can define it as a product of mass and velocity. Then we studied about potential energy. What is potential energy? Come on children, think once. Potential energy, children, any body means if the energy possessed due to by virtue of its state of rest or state of position, that is a state of position and or a configuration is called actually potential energy. There we studied about elastic potential energy and what next, what elastic potential energy, next gravitational potential energy. That's good. Then finally we discussed about work energy theorem. So here work done by any force, work done by a force, if it is like in the direction of motion of the object, is always equal to the increase in its kinetic energy. In today's session, dear children, we are going to solve a numerical based on these concepts only. So before going to start our numericals, let us recall some important formulas, what should be in our mind, so that we can do the numericals in a easy way. Look at here, children. Here this is what potential energy means. When an object, for example, it is object already at a certain height, so due to which it possesses some potential energy. So how can we calculate potential energy at a given height? For a given height, how can we calculate the potential energy? So that is potential energy is equal to mgh. Children, we know that potential energy mainly depends on the height, so that is proportional to height. So we can write it as a P1 by P2 is equal to H1 by H2. Next, children, already the body is at a certain height, already let us suppose 2 meters, already at a certain height H1, and again it is taken from H1 to some more height. So definitely there will be an increase in potential energy. Already it has a potential energy because it is placed, let us say it is Earth's surface, already it is placed at a certain height. From here, from H1, again it is taken to some more height. So definitely there will be a change in potential energy, there will be an increase in potential energy. Then how can we calculate that change in potential energy? So here is, so change in potential energy is equal to mg into H2 minus H1. Next, kinetic energy is half mv square. Children, for a given mass, it's very important. For a given mass, kinetic energy is proportional to the square of the velocity. So we can write here ke1 by ke2 is equal to v1 square by v2 square. For two bodies, if two bodies are moving with the different velocities, then how can we calculate the ratios of the kinetic energies? So this is what actually we can use a formula. Next, children, here is kinetic energy is equal to, it's a relation between kinetic energy and linear momentum. So kinetic energy is equal to p square by 2m, or p is equal to square root of 2mk. Children, here once again I want to tell you a very important point. See, when a velocity remains constant, kinetic energy is proportional to mass. Don't get confused, proportional to mass, it's very important. When velocity remains constant, kinetic energy is proportional to the mass, means more the mass, more the kinetic energy, less the mass, less the kinetic energy. Whereas when linear momentum remains constant, for a given two bodies are going such a way that both will have a same momentum, same linear momentum, but different mass. Then dear children, kinetic energy is inversely proportional to mass. Don't get confused, it's very important. Means what? When two bodies with different masses are moving with the same linear momentum, then the lighter body will have more kinetic energy, whereas the body with more mass will have less kinetic energy. It's very, very important. Now come to the work energy theorem. So children, whatever the work is done by the force is always equal to the change in its kinetic energy. So children, these are the very, very, very important formulas which we are going to use to solve the numericals. Just note down. Children, in the first question, it is given that two bodies with the same mass. So the mass of this body is m only, the mass of this body is m only. But thing is that both are placed at different heights, such a way that this first one is placed at a height h and the second one is placed at a height 2h. They are asking us to calculate the ratios of gravitational potential energies. Children, gravitational potential energies due to the change in height as we told. So here it is placed at a certain height h, it is placed at a certain height 2h. Then how to calculate the ratio between gravitational potential energies? Children, we know that potential energy is equal to mgh. But dear children, here mass remains constant and at a given place g also remains constant. Then potential energy is proportional to the h. So what can we write? We can write potential energy is proportional to height. Potential energy is proportional to height. So this, let us apply to this situation. There we can write, so potential energy of first body by potential energy of second body is equal to it is h1 by it is h2. So here h1 is given how much? It is h, that is here is h, h2 is equal to it is a 2h. So h gets cancelled, so we got here is a 1 by 2, that is PE1 by PE1 is 2, PE2 is equal to it is 1 is to 2. So this is how we can calculate the ratios of gravitational potential energies. And look at the second numerical here, even look at the numerical on the screen also. Children, it is given that a body of mass 1 kg is already at a certain height 5 meters. So definitely children, as it is placed at a certain height, definitely it possesses some potential energy. Now they are asking us to calculate that gravitational potential energy if g is equal to 10 meter per second square. So this is actually direct numerical based on this formula only, that is P is equal to mgh. Potential energy is equal to mgh. So children, mass is given how much here? Mass is given 1 kg, that is 1 into g value is given 10 meter per second square, it is 10, and h is given 5, so it is a 5. So 1 into 10 into 5, it will be 50. Children, then what are the units? It's a very, very important. Of course, getting answer is very important. At the same time, giving a units, correct units you must give. What are the units here? Potential energy. All are given in SI system, dear children. It is SI only, SI system only. So what is the SI unit of energy? Joule it is. So it is 50 joule. This is how we can calculate. Okay children? Fine. Now look at the third numerical. In third numerical, what is given? A box which is weighing 150 kgf is placed at a certain height such a way that it possesses some potential energy. Children, already it has a potential energy. Why? Already it is placed at a certain height. Now they are asking us to calculate the height. So where the particular object, where the box of weight 150 kg is placed, so that it has potential energy of 14,700 joules. So this time potential energy is given, weight is given, not mass, weight is given, and they are asking us to calculate the height. Let us calculate here. Children, before going to do that, it's very, very important. One important point we should remember. Here kgf we have to convert into newtons. Kgf we have to convert into newtons, very important. So 1 kgf is equal to, how can we take 1 kgf is equal to 9.8 newtons. It's very important. So first let us convert, children. So here W is equal to 150 kgf. So 1 kgf is equal to, we can write 9.8 newtons into 9.8 newtons. So we get it as a 1470 newtons we got. Yes, we got here W. Children, it is nothing but mg. Can I write like this? Of course, W is equal to mg. We can say it is a mg is 1470. Children, or else, you know, we can do like this also. From 150 kgf, we can calculate mass. Again, mass into g value. Again, same thing you will get. Nothing makes different. Nothing makes different. Now let us see. We know that potential energy is equal to mgh. Potential is equal to mgh. What we have to calculate, children? Here we have to calculate the height, where that box is placed. Where is the box is placed? So that its potential in G is 14,700. So here H is equal to potential energy by, children, mg. That is mg. So is equal to. So potential energy is given how much? 14,700 by this we got 1470. So it is ones, it is tens. So here H is equal to 10 meters is the answer. Which means what? The box of weight 150 kgf should be placed at 10 meters height from the ground so that it possesses 14,700 joules of potential energy. That is a gravitational potential energy. Okay, children, copy it. Children, look at the question number 4. It is given that a ball of mass 5 kg already at 10 meters height from the ground, 10 meters height, and it is falling from 10 meters height to 4 meters height. So children, try to understand. As there is a decrease in height 10 meters to 4 meters, obviously there is a loss in potential energy. Now we need to calculate that loss in potential energy, and also we need to calculate the total energy at any point. Total energy at any point. First, let us calculate the loss in potential energy. Children, here mass is given actually 5 kg. So here mass is given 5 kg and initial height, let us take as a 10 meters. Let us take it as a h1, or you can take h2, it's not a matter. If you take this as a h1 and you can take this as a h2, it's not a problem. So h2 is equal to 10 meters. And here h1 is given how much? It is the 4 meters, and g value as usual is the 10 meter per second square only. So children, here the loss in potential energy is equal to mg, you can calculate h2 minus h1. Children, you can calculate like this directly, or else you can calculate the potential energy at a height 10 meters and you can calculate the potential energy at a height 4 meters, then you can subtract. Like that also you can solve. Either of one is okay. So here mass is given how much? It is given 5 kg, g value is a 10, then h2 minus h1 is how much? h2 minus h1 is, so here h2 is a 10 meters which we have taken, minus it is 4 meters, then it is 50 into 10 minus 4 is a 6, so it is how much, dear children? 300 joules. So 300 joules is not a energy possessed by the body, dear children. It is loss in potential energy. So as this much of loss is there in potential energy, then what is the total energy at any point? At any point they are asking us to calculate the what is the total energy. Children, here one very important thing we can say, very easily we can calculate the total energy at any point. They said at any point. Then let us take, why don't we take at this point only, at a point A only, at a point A and at a point B, let us see. At a point B. So at a point A, it possesses maximum gravitational potential energy. Maximum gravitational potential energy. How can we calculate? How can we calculate? It has only potential energy. So that is, only potential, maximum potential energy at a point A. And when the ball is going to hit the ground, as the ball is falling through a height of 10 meters, it is going to hit the ground like this. It is going to hit the ground. Children, before going to hit the ground, means almost its height is negligible. So potential energy is 0. It has maximum kinetic energy. So the maximum potential energy at a point A is equal to maximum kinetic energy at a point B. So this we can calculate it by using it is mgh. Here h is what? Initial height, this height we should take. We should take this height. So it will be 5 into 10 into 10. So this is how much it is. Total it is a 500 joules is the total energy possessed by the body of mass 5 kg at any instant of time. At any instant of time. So don't get confused. Sir, here a kinetic energy formula is half mv square, but how can you take here? Children, according to law of conservation of energy, in next class we are going to discuss in detail about this. So there is a change in energy. Here the amount of energy it might be same only, 1000 joule only. Here also 1000 joule only. Its form is different. Before it was potential energy. Before going to hit the ground, it is a kinetic energy. That's it. Okay, children. This is how we can calculate the loss in potential energy and total energy at any instant, at any point is how much? 500 joules. Copy this. Here a body of mass 0.5 kg it is given. Means in order to lift the body of mass 0.5 kg through a certain height, the energy spent is 1 joule. Then through what height this body is lifted? So we have to calculate this height so that the energy spent is 1 joule. So your g value is given 10 meter per second square. So we need to calculate what is height we need to calculate. Let us do that. So we know that here potential energy is equal to mgh. Children, here it is said that this much energy is spent, but as there is a change in the position, definitely whatever the energy which we spent is stored in the form of potential energy only. So that is P is equal to mgh. So potential energy is given 1 joule is equal to mass is given how much? 0.5 kg and g is given how much? It is 10 meter per second square. That is 10 meter per second square, and height to be calculated. Height to be calculated that. So it is 1 is equal to 0.5 into 10 will be 5 into h. Okay. Then h is equal to it is 1 by 5. So therefore it is 0.2 meters. 0.2 meters. So this is how we can calculate, children. So the body of mass 0.5 kg, okay na, is taken to a height of 0.2 meters, so that the energy spent is 1 joules. The energy spent is 1 joules. Clear? Fine. Now we'll move to the next numerical. It seems to be very interesting, very simple also. Look at that numerical. Look at that. So what is given to children? A boy of weight 25 kgf initially is at a ground floor only, no doubt. And what is happening? First he moved to a ground floor of height 3 meters. Then he moved to a height of 5 meters to first floor. Then what is asked? What we have to calculate? Obviously the change in gravitational potential energy we need to calculate. Change means what, children? Here increase in gravitational potential energy, because the height, the position is changed, the position is increasing. So obviously there will be a increase in gravitational potential energy that we need to be calculated. Now look at here. What is given here? 25 kg of children. So as usual here W, that is mg is given 25 kgf. 25 kgf. Children, KGF, it's not a movie name, right? KGF chapter 1, chapter 2. It's a really awesome movie. Okay, fine. Look at here. So as it is given in a KGF, but in exam don't write about KGF. Okay, yes, here. So KGF we have to convert it to newtons. Children, 1 KGF is equal to 10 newtons. Don't forget this. Still, it's very important. Many children are doing this mistake only here. 1 KGF is equal to 10 newtons. First, we have to calculate. So this will be 25 into 10 is equal to 250 newtons. So this what actually W, and it is also equal to mg. Okay. Now here let us say the initial height is a h1 is a 3 meters, let us say. So this is h1 is 3 meters. So h2 is 5 meters. Children, individually we can calculate the gravitational potential energy at a height 5 meters, 3 meters. You can subtract so that this will give you change, that is a increase in potential energy. If not, we can have this formula here. P is equal to mg into it is h2 minus h1. That's it. We got it. Finished. Now directly you can substitute the values. You will get the answer. Children, let us do it. Let us do it together. M is given how much? Sorry, why M? Already mg we know, right? Mg is known, that is 250. 250 into H2 is how much? 5 minus 3. It is 5 minus 3. So it is 250 into 2. This will be 500 joule. 500 joule. So children, when a boy of weight 250 newtons, when he moves from a first floor to second floor, first floor is at a height meter 3 meters and the second floor is at a height 5 meters. Then what will happen? There is a increase in gravitational potential energy. How much it is? It is 500 joules of energy. 500 joules of gravitational potential energy. It is an increase, children. Why it is increase? There is an increase. The change in a position means the height is increased. So whenever the height increases, what happens? The gravitational potential energy also increases. Okay, dear children. In this question, it is given that a vessel is consisting of 50 kg of water is placed at a height of 15 meters. Children, don't get confused. How can we keep like a vessel of water in air? Something magic is that. It is not that. Just assume here might be some wall, or else somebody is holding. Just imagine it. Otherwise, how can we keep like containing water container with water simply at a certain height of 15 meters? So it is not possible. Just assume. Just it is an assumption. Yeah, physics means assumption. Physics means imagination. That is very important. Okay, fine. So when it is placed at a height of 15 meters, so definitely it possesses some gravitational potential energy that they are asking us to calculate. So here mass is given 50. So here mass is given, it is 50 kg, and here height also given 15 meters. So how to calculate the gravitational potential energy? That is potential energy is equal to mgh. So here as mentioned, mass is given 50, mass is given 50 and g is given 10 and h is given 15. H is given 15. So how much it will be? It will be 7500 joules. 7500 joules of gravitational potential energy. Okay, children, fine. And look at here, this question. A person is climbs up a ladder of height 10 meters and there he is sitting nicely. Again, you may ask questions, sir, how it is possible? Who is holding that? Don't think that here somebody is holding and somebody is getting. It's not that. This guy only just going and he climbs up and sits at a height of 10 meters on the ladder here. Just imagine, I said, now, of course, some talented people will be there. They only can hold the ladder and they will be climbing. That could be different. That could. Children, there also our concept called what? Center of gravity is matter. So by using that concept, they may do it. Okay. Whereas for an ordinary person, it is not possible. Definitely will fall and we have to admit in the hospital. That's it. Okay. Children, don't try this. Don't try this. Okay. Yes. Come here. What is given is that a person climbs up a ladder of height 10 meters. His mass is 50 kg, and what is the increase in gravitational potential energy when the person as is climbing up? So what is the increase in gravitational potential energy, or else we can say like this: what is the gravitational potential energy of this boy of mass 50 kg when he sits on a ladder of height 10 meters? So simple. Again, let us use the same concept. That is, potential energy is equal to mgh. Same formula here. So m is given directly, it is a 50 only, 50. G is given, it is a 9.8. Children, G value every time don't substitute 10 only. It is not that. It depends, numerical, it depends. So if it is given 9.8, you can substitute 9.1 only. If it is given 10, you can substitute in 10 only. So let us not use R this one. What 9.8 in a previous numerical, for example, we substituted 10. Let us substitute in 10. It is not that, children. Whatever is given, that we have to substitute. So here into height is how much? 10 it is. So this will be how much? 50 into 98. So it is 98. So it is 4900 joules of gravitational potential energy when a person climbs up, a ladder. Okay, children, just copy this question. In this question, dear children, it is given that there is a slope. There is a slope here, and at this slope edge means almost it is the ground only. a block of weight 100 newtons is there, block of water weight 100 newtons is there, and here we are like applying some force, it's pushing, we are pushing, so and for that we are applying 100 newtons of force, so that we can take from this point to this point. Finally the block may reach here, children. Here as we are applying force and the body is displaced, definitely the work is done here. So thing is that we need to calculate the work done along the slope. Let us say, name it as it's a QR. Let us calculate the work done along the slope QR. So we know that here we have to calculate the work done, children, along the slope QR. So what is the work done here, children? Already we discussed. So force into displacement. Why are we not taking here theta? Because the body is displaced, the body displacement is in the direction of applied force only. So let us take here, it is a force into displacement. Here force into displacement. But force is what here? Mg. So dear children, so the force whatever we are applying is a weight, is it's a mg only. So it will be, it is 100 newtons. 100 newtons, no need to substitute newton. And S means displacement, means how much we should take, dear children, displacement. Displacement is given how much, dear children? The body is displaced along the slope. So it is given the length of the slope is 5 meters. So it will be S is equal to QR, that is a 5 meters. It is given 5 meters. So 100 into 5 will be, it is a 500 joule. It is 500 joule is the first one. And in numerical, still what they are asking? They are asking us to calculate the increase in potential energy. Children, of course, we are pushing the block along the slope. At the same time, the height also increasing right from the ground, due to which the block possesses some potential energy, gravitational potential energy. How to calculate that? So that we can calculate with mgh. W here PR is equal to mgh. Children, we need to consider this height. This height we need to calculate. So here, anyhow, mg is what? Force, gravitational force acting in the block is given, it's a 100, and height is given, children. The body is lifted indirectly as we are sliding here. Indirectly, body is lifted through a height of 3 meters. So it is a 3. So here it is 300 joules of energy. 300 joules of energy. So it's a very, very important point is that actually, when we are pushing along the water inclination, so the work done is 500 joules, means indirectly the body is lifted, so there it possesses 300 joules. Actually this both should be same, but there is a difference, means in the first case some extra 200 joules is needed. If you can look at here, so here you know the loss is how much? The loss in energy, it's like, you know, here extra 500 joules, so it is 500 minus 300. So children, here 200 joules extra energy is needed. Why this extra energy is needed? To move the block along the inclination. Children, the reason is that it is not a smooth surface. It is not a smooth surface. So definitely there will be friction as we are trying to push the block. What will happen? Friction will act opposite the direction of push. So we need to spend extra 200 joules of energy in order to overcome the friction. But whereas here there is no friction. Of course, here air friction is neglected. Anyhow, as we are moving the block here, definitely here there will be height. That is different here. But let us think about this surface only. So this surface is not smooth surface. It is a rough surface, so that it offers some friction. To overcome that friction, extra 200 joules of work is done, or extra 200 joules of energy is spent. If you talk in terms of energy, extra 200 joules of energy is spent. Okay, children, copy it. Children, here body of mass 5 kg and it is going with a 10 meter per second. So obviously, dear children, as the body is in motion, obviously it possesses kinetic energy. Then how to calculate that kinetic energy in a given question? So it is given that mass is given 5 kg and the speed is given 10 meter per second, and we know that kinetic energy is equal to half mv square. So here it will be half, mass is given 5, the v square is a 10 square. So 10 square is what, children? 100. So here it will be 1 by 2 into 5 into 100 it is. So 2 ones are, so it is a 250. So 50 into 5 will be how much? It is a 250 joules. So if a body of mass 5 kg, if it is moving with a velocity 10 meter per second, obviously, so then what is its kinetic energy? Its kinetic energy is 250 joules. Look at here, question number 11. It is given that car. So the car is in motion. Car is in motion. Children, what is that car? What is the name of the car? Here, name of the car and a company is not at all needed here. Let us see. Initially, when the car is moving and we have taken a certain point. At a point A, its velocity is v. Of course, fine. Now, when the car has reached at a point B, its velocity is halved. For example, here 10 meter per second, here 5 meter per second, here 100 km per hour, here 50 km per hour, like that. Then, what is the change in its kinetic energy they are saying? Children, do you think that there will change in its mass of the car? No, it's a quite ignorance. We cannot. Of course, it is possible when the car should go with a greater the speed of the light. That is 3 into 10 power 8 meter per second. It is not possible. So, mass is not at all changed. The thing is that only here velocity is changing. Obviously, kinetic energy also gets affected. Why? Kinetic energy is proportional to the square of the velocity. So, look at here. We know this formula. Kinetic energy is equal to half mv square. But children, here half and m remains constant. So, then here kinetic energy is proportional to v square. Kinetic energy is proportional to v square. Then can we write like this? Ke1 by Ke2 is equal to v1 square by v2 square. Children, we can use this formula directly, or else you can calculate kinetic energy individually. Let us calculate here kinetic energy. Children, here. So, here kinetic energy at a point A will be half m v square. Here, what is the kinetic energy here? Kinetic energy at a point B is half m, but here it is v by 2 whole square. V by 2 whole square. So, here this will be half m, it is v square by 4. V square by 4. So, children, can we write like this? 1 by 4 into half mv square, half mv square. But you tell me here, what is this half mv square? Half mv square is the kinetic energy of the body at a point A. So, substitute that. So, here kinetic energy of the car at a point B is equal to 1 by 4th of kinetic energy of car at a point A. Which means what? When the speed is halved, then kinetic energy is reduced by 4 times. It's very, very important, children. It's very, very important. When a velocity is reduced to half, then the kinetic energy is reduced to 1 by 4th. Okay, children? Fine, copy it. Children, here is one more similar question here. But the difference is that before, same car at a different positions we have taken. But here, 2 different masses, 2 different bodies. But the condition is that both have same mass. 2 bodies with the same mass, but moving with different velocities. So, let us say it is a body A and it is a body B. So, that is a very convenient to us to do it. Now, what is the ratios of kinetic energy of these 2 bodies? Children, it has some velocity, so it possesses some kinetic energy. It has some velocity and it also possesses some kinetic energy. Then, what is the ratios of the kinetic energy possessed? So, let us calculate the individual. Children, as I told you that we can calculate the kinetic energies individually and you can find the ratios. If not, the formula as we discussed just before, kinetic energy kinetic energy of block A by kinetic energy of block B is equal to velocity square of like a first body to the velocity square of the second body. Why? Because here as mass is constant, so kinetic energy is proportional to the square of the velocity. Square of the velocity. Now look at here. Children, here VA is what? V, and VB is what? It is 2V. 2V. Now look at here, substitute here. So it will be V square by, it is 2V square. So children, it will be how much? It is V square by 4V square. 4V square. 4V square. Children, here I will tell you here, some students are doing a mistake here. What is that mistake? Instead of substituting here, V square by 2V whole square, they are substituting like this only. So what happens? V square will get cancelled. They are getting 1 by 2. They are thinking that yes, I got a correct answer, but answer is 0 over that. So you must be very careful. So it is a whole square. It is square is not only for Vd children. So 2V whole square is very, very important. So this will be V square by 4V square. V square will get cancelled. It will be 1 by 4. And one more important dear children, as they are asking us to find the ratio, let us write in the ratio form only. Don't leave like a P by Q form. It's not correct. Okay. So here kinetic energy of body A is to kinetic energy of body B is equal to 1:4, which means what? As a second body with the same mass is moving double the speed, then its kinetic energy is increased by 4 times. Children, in the previous numerical we discussed, when the velocity is reduced to half, kinetic energy is reduced by 4 times. But whereas when the speed is doubled, when speed is more, means that is 2 times, then kinetic energy is becoming 4 times. Got it? 13th numerical, the question is shown on the screen also, children. What is given here? 2 bodies, but by this time not with the same mass, and mass is not mentioned, children. It is mentioned that the masses are in the ratio of 5:1, that is, it is a 5m, it is m, and as these both are in motion, they said, so it has some velocity, let us say it is a Va, it has some velocity, it is a Vb, such a way that the ratios of kinetic energies are given 125:9. Then what is the ratio of the velocity of these 2 bodies with the different masses we need to calculate? Children, till now we have discussed the case where mass remains constant, so that by using the concept kinetic energy is proportional to V square, we calculate it. But by this time mass also involved, look at here. So as we know that kinetic energy is equal to half mv square. Now let us apply this formula for body A and body B. Children, here kinetic energy for body A we can write as a half MA square. So for kinetic energy for body B we can write like this. It is half MB and it is VB square. Then they are asking us to calculate ratios of their velocities. So let us say it is equation 1, it is equation 2. Children, just divide the equation 1 with the equation 2. Then what will get if you divide these 2 equations? You will get kinetic energy of body A by kinetic energy of body B is equal to, we will get 1 by 2 MA VA square by half MB, it is VB square. So the half of gets cancelled. Children, the ratios of kinetic energy is given 125/9. So right here it is 125/9 is equal to. So the ratios of mass is also given, that is how much? 5:1. So it is a 5/1 into, it is VA square by it is VB square. 5 ones are 5, 25s are. So we got here it is VA by VB whole square is equal to 25/9. So from here, dear children, VA by VB is equal to square root of 25/9. So this is 5/4. So therefore the velocities ratio VA is to VB is equal to 5:4. This is how we can calculate. It's very simple means very simple. Just copy it. In a question number 14, dear children, if you can look at here, it is given that, children, two similar cars means it's not belongs to same company, it is not a matter here. Two similar in the sense what? Both have same mass, otherwise don't think, is it like an ambassador, is it like a bracer? It's not that. Similar means it's not that, it's the same company. In terms of science, we are taking it as a same mass. So here, two cars with a similar mass, similar cars moving with, the first one is moving with a 15 km per hour, second one is going with a 45 km per hour. Then what are the ratios of their kinetic energies? Children, here some of you may get doubt, sir, should we convert kilometer per hour into a meter per second? It is not required here. If you will convert, if not, we will get the same answer. Then why do convert? It's a time waste. Okay. Children, here as they said that the mass of the car is m, here the mass of the car is m only. When mass remains constant, we know that kinetic energy is proportional to the square of the velocity. Let us say it is a car 1, first car, and it is a second car. So it is kinetic energy of first car by kinetic energy of second car is equal to how much? How can we? So square of the velocity of first car to the square of the velocity of second car. Children, V1 is given how much? 15 square by V2 is equal to the 45 square. 45 square. So can I write like this? 15 by 45 whole square. Of course, we can write. It is possible. So 15 ones are 15 threes are. So 1 by 3 whole square, that is 1 by 9. This is a 1 by 9. So therefore the ratios of kinetic energy of these two similar cars is 1:9. Why it is 1:9? Because the second car is going 3 times more speed here. Try to understand. The speed of the car is 3 times than that of this first car. So that the kinetic energy is increased by 9 times. The kinetic energy is increased by 9 times. Clear? Here in this question, it is given that a body of mass 0.5 kg initially moving with 5 meter per second. Then its speed is reduced to 3 meter per second. Then what is the change in its kinetic energy? Children, obviously, as there is a decrease in velocity, so kinetic energy also decreases. And the body velocity is decreasing, so we can say the body is moving with deceleration. So obviously, we may get kinetic energy negative value. Do we get negative value? Let us see once. Here how to calculate? Let us calculate at this position kinetic energy. Let us calculate. So here it is. Kinetic energy is equal to half. Mass is given how much? 0.5. Half mv square formula. Half mv square formula. 0.5 into it is a 5 square. So it is 0.5 into 25 by 2. And if you can do this, you will get 6.25 joules. 6.25 joules. 6.25 joules. So here at this position, kinetic energy will be how much? Kinetic energy is equal to half into mass is 0.5 and the velocity is reduced to 3 meter per second. That is 3 square. So it will be 1 by 2 into 0.5 into 9. So this will be 4.5 by it is 2. So how much do we get? It is 2.25 joules. 2.25 joules. So children, they are asking us to calculate the change in kinetic energy. So this is final kinetic energy and it is initial kinetic energy. So change in its kinetic energy is equal to final kinetic energy minus initial kinetic energy. So this will be, so 2.25 minus 6.25. So how much we are getting here? It is minus 4 joule actually. Minus 4. Children, here you will get one dot actually. Kinetic energy formula is half mv square. Here m is a mass, is a scalar, always positive. And here velocity might be negative, but its velocity square is. So it is also positive. So always kinetic energy is positive. Yes, it is true. But here then why do we get minus here? Children, it is a change in kinetic energy, not kinetic energy. Kinetic energy is always positive only. Here change in kinetic energy. Here minus, what does it represent? Minus represents that the kinetic energy of the body is decreasing. The kinetic energy of the body is decreasing. Okay children, this is how we can calculate the change in its kinetic energy. If the body velocity is increasing, then we will get a positive value for a kinetic energy. Positive value for a kinetic energy. And so look at here. A bullet is fired from a gun. Its mass is 500 grams. Such that it is moving with a 15 meter per second. Then as the body is in motion, dear children, it possesses kinetic energy. At the same time, it has some linear momentum also. So we need to calculate a linear momentum of this bullet fired with a speed of 15 meter per second and mass of 500 grams, and its kinetic energy also we need to calculate. First let us calculate the linear momentum. So easy it is. So linear momentum formula we know is a mass into velocity. But children, here mass is given 500 grams. This need to convert into kg. That is 0.5 kg it is. It is 0.5 kg. Now substitute here it is. So it is 0.5 into velocity is given how much? Velocity is given 15. Velocity is given 15. So it will be how much? How much do it? So it is 7.5. But 7.5 units. Mass is measured in kg. Velocity is measured in meter per second. So it is 7.5. So the bullet with a mass 500 grams, when it is fired with a velocity of 15 meters per second, it has a momentum 7.5 kg. kg meter per second. Then how to calculate kinetic energy? Let us use the same formula. It is kinetic energy is equal to half mv square. So it will be half into mass is given 0.5. V square is how much? It is 15 square, children. 15 square. So this will be 0.5 into 15 square is how much? It is 225. By it is 2. So this will be 0.5 into 112.5. This will get 56.25 joules of kinetic energy. So children, if a bullet of mass, children, 500 grams might be very small only, but as it is in velocity, it possesses some kinetic energy. That's what, children, we don't dare to go across the bullet which is fired from a gun. Why? It might be very small in mass, but as it is in motion, it has a kinetic energy and momentum. So it has the ability to kill a person actually. Okay, children, just copy it. In this question, it is given that a body of mass 10 kg is moving with a 20 meter per second. Then what happens? What is its kinetic energy when its mass is doubled and velocity is reduced to half? Children, is it possible? Like, let us, it's a situation, it's a 10 kg mass is going with. Suddenly it must become boom, like this it became. Of course, in a reality it is not possible, but in assumption everything is possible. Assumption everything is possible. So, the body of mass 10 kg means you can take like this also. Some mass is added suddenly. So that of course the mass is doubled. See, mass is doubled means not that same body should be like this. It's not that. Some extra mass is added suddenly. In a fraction of seconds it is added. So that its mass is doubled and its velocity is reduced to half. Then what is its initial kinetic energy and what is its final kinetic energy? Let us calculate here initial kinetic energy, that is KEI, initial kinetic energy. Children, kinetic energy formula, it is half mv square, half mv square. So it will be half, mass is given how much? Mass is given 10 and velocity is 20 square it will be. So children, 2 ones are, it is 2 5s are. So it is 5 into, it is 400. So 5 into 400 will be 2000 joules. So this is the initial kinetic energy. Initial kinetic energy. Now let us calculate the kinetic energy when the mass is doubled and the velocity is reduced to half. So it is given that kinetic energy of final, it is half. So children, mass is doubled. Mass is doubled means it is 10. So it will become 20. So that is 20. Velocity is reduced to half. Initially it is moved to 10 meter per second. Now it is 10 meter per second. So it is 10 square. 2 ones are, it is 2 tens are, it is. So children, it is 10 into 100, 10 into 100. So it will be 1000 joules of kinetic energy. So children, look at here the impact of velocity. Impact of velocity, impact of mass actually. So here when mass is doubled and the velocity is reduced to half, then the kinetic energy, before it was 2000 joules, but it is reduced to 1000 joules. This is the impact of mass and velocity. That's what we can say, that kinetic energy depends on mass and as well as velocity. Of course, it depends on frame of reference too. Okay children, copy it. Children, now we are going to solve the numerical based on work energy theorem. What is the work energy theorem? Children, according to work energy theorem, it is final kinetic energy minus initial kinetic energy. That is this what. So based on this, we are going to solve the numerical. Children, what is given here? So velocities are given in a kilometer per hour. First, we need to convert into meter per second. Children, we know that 1 kilometer per hour is equal to how much, children? It is a 5 by 18 meter per second. 5 by 18 meter per second. So here, as u is equal to 36 kilometer per hour. So let us take it as a 5 by 18. 18 ones are, 18 twos are. So it is 20 meter per second. 20 meter per second. Then what is final velocity? Final velocity will be 72 into. So kilometer per hour is equal to 5 by 18. So it is a 5 by 18. 18 ones are here, 18 4. That is 4 into 5 is how much? It is a 20 meter per second. So initially the truck is moving with a 10 meter per second and its velocity is increased, speed is increased in 2 minutes to 20 meter per second. Then we need to calculate the work done actually. Children, in order to calculate the work done, we need to have mass also. But here mass is not given. Here gravitational force acting on the body is given. Children, here you should know that what is 1 kgf? What is 1 kg of d, children? For suppose, children, here the body of mass 1 kg is there. The body of mass 1 kg is there. So, the force which is acting, the gravitational force acting on the body of mass 1 kg only, we can take it as a 1 kgf. So, here 1 kgf is a gravitational force acting on the body, then the mass is 1 kg. Then here 1000 kgf is there, then what is the mass here? 1000, that's it. It is a 1000 kg. The mass is 1000 kg. Now, let us apply this work energy theorem to calculate the work done. So, children, here we can take mass as a common like this. W is equal to, we can take here half m, we can take as a common v square minus u square. V square minus u square. Let us substitute the values here. W is equal to, what is given here? 1 by 2. Children, mass is given how much? 1000. Fine. And the velocity is given how much? So, 20 square. 20 minus 10. Children, can you write like this? Can you write? Many children will do mistake here only. They will write 20 minus 10 whole square. Children, it is a big mistake. You cannot do like that. It is v square minus u square. It is not a v minus u whole square. V square minus u square. So, we have to write 20 square minus 10 square it is. So, this will be 2 ones, it is 2 500s. So, children, it is a 500 into 500 into this is 400 minus 100. Children, 400 minus 100, it is a 300. So, it is 500 into 300. So, 5 3s are how much? It is a 15. Just put 4 zeros. So, here it is a 1,50,000 joule of work is done in order to make the truck to move into, to change its speed from 10 meter per second to 20 meter per second. Now, they are asking us to calculate the power of the engine here. So, what is the power of engine? How can we calculate, children? We know that power. Children, what is power? A rate of doing work is called power. So, we can calculate the power in terms of work and time. Children, we know that power is equal to work by time here. Work is given how much? Here we got 1,50,000 we got here. But time, can we substitute 2 minutes directly? No, we cannot substitute. So, that to be converted into seconds. Children, 2 minutes, 2 into 60. So, we convert it into seconds. So, here 0, 0 cancel. So, this will be 15,000 by 12. Get 1250 watt. So, this also we can write 1.250 into 10 power 3 watt. So, 10 power 3 we can write as a kilo. So, this will be 1.25 kilowatt is a power. Children, this is how we can use the work energy theorem. And here only one thing, children. Many students, without converting into seconds, they will do that. So, you convert so that you will get a work done. Then you can calculate the power. Copy it. Children, here it is given that a body of mass 60 kg is moving with linear momentum of 3000 kg per meter per second. Then what is its kinetic energy and with what velocity the body is moving? Children, we know the relation between kinetic energy and the linear momentum. That is, kinetic energy is equal to P square by 2m. You can use this formula, or else directly you can calculate velocity. Children, here also from this we can calculate the kinetic energy. If not, first you can calculate the velocity, because momentum is equal to mass into velocity, we know that. So, momentum is given, it is 3000, mass is given how much? 60, so into velocity. So, from here 0, 0 cancel, 6 1s are 650. So, here velocity is given 50 meter per second. Velocity is given 50 meter per second. This is how we can calculate. Then how to calculate kinetic energy? So, from here we know that kinetic energy is equal to half m v square. Then here half mass is given how much? 60. Velocity is how much, dear children? 50 square we got. 50 square we got. So, 2 1s are 2 30s are. So, this will be 30 into 50 square is how much? 2500. 2500. So, you can calculate this, how much we are getting? This 7530. So, this we can write as a 7.75, or else we can write 7.5 into 10 power 4 joules of kinetic energy. Children, if they don't ask you to calculate the velocity, then directly you can use kinetic energy is equal to P square by 2m. P square by 2m formula you can use directly to calculate. Whenever mass and momentum is given, you can calculate like this, or else if you can calculate the velocity, then you can calculate the linear momentum. Okay children, fine. Now in the next question is almost similar to this only, almost similar only, but the difference is that here the mass is given, the mass already given is 50 grams of body. In order to give a momentum of 5 kg meter per second, what is the work done? So how much work should be done in order to give a momentum of 5 kg meter per second to the body of mass 50 kg. So here what is given to children here? Mass is given 50 grams. So let us convert into kg. This will become 0.05 kg. And the momentum is given how much here? Momentum is given, it is 5 kg meter per second. Dear children, whatever the work is done in this case is stored in the form of what? Kinetic energy. Children, in this case, whatever the work is done is stored in the form of actually kinetic energy. So here kinetic energy is equal to, so work done is kinetic energy is equal to half mv square, half mv square. So here how much will be getting here? Half, mass is given 0.05, here here whatever the work is done is stored in the form actually kinetic energy. So how kinetic energy is related to momentum? Children, we know that kinetic energy is equal to P square by it is 2m. So this is actually work done. So P square means it is a 5 square by 2 into it will be 0.05. So children, this will be 25 by it will be 0.1. So you will get it as a 250 joules. So 0.1 we can write as a 1 by 10, that 10 will go to the numerator. So 25 into 10 will be 250. So this is how we can calculate. Children here, so in order to give a momentum of 5 kg meter per second to a body of mass 50 grams, 250 joules of work is done. 250 joules of work is done. In this question, it is given that a person is like holding 30 kg mass on his head. For example, here like this, one head and he is holding. So then what is the energy given? What is the energy? See, as a person is continuously standing like this. So children, first, if you want to calculate the energy, means we know that energy is equal to the work done. What is the work done in this case? Can you say that? The children, means as the fixed height, let us say from here is the reference point is this one. So from here, in this case, what is the work done as a person is holding? So no work is done. As no work is done, what actually? No energy is spent. That's it. No work is done and no energy is spent. So whether the person can wait 5 minutes, 10 minutes, 15 minutes, 24 hours also if he can wait. So the work done is 0, which means what? The energy spent is 0 only. The energy spent is 0 only. Now in a second case, the thing is that by holding 30 kg what of mass, the person is running. Generally, children, just imagine the situation. Sometimes what will happen, you know, we want to catch a bus, and bus already just started. What we'll do? We'll keep like this, and we'll be like running like anything. We'll be running, we'll be running. So of course, after that we may or we may not catch. But by holding luggage, we'll be running. Just imagine a situation where person is holding a luggage of mass 30 kg and he is running with a velocity of 3 meter per second. Then in this case, what is the energy spent? What is the energy spent? So as a person has certain velocity, so definitely the body has kinetic energy. So it is kinetic energy is equal to what children? It is half mv square. So it is half into mass is given how much? 30 and the velocity is 3 square it is. So it will be 2 ones are 2, 15 it is. So this will be 15 into 9. 15 into 9 is how much? So this is 135 joules of energy he must spend. And just now imagine the person like ran like anything and finally he caught the bus. And he has to keep luggage on the top of the bus. Just you think. So the person is trying to keep is luggage, mass of 30 kg is keeping on the top of the bus. In order to keep on the top of the bus, it is raised to 0.5 meters height. The luggage of mass 30 kg is raised to 0.5 meters. Then in this case, what is the energy spent? The children, now the person is not running. Yes, he caught the bus and is standing, but he is lifting his luggage. So there is a change in position. So there is a change in position, definitely. The body has gravitational potential energy. Body has gravitational potential energy. So how to calculate that gravitational potential energy, children? So the gravitational potential energy can be calculated with mgh. So here mass is given how much? 30. G is 10 meter per second square, and h is how much? 0.5. So it is 0.5. So it will be 30 into 10 into 0.5 will be, it is a 5. So 30 into 5 will be how much? It is a 150 joules of energy. 150 joules of energy. So children, so this is how actually we can calculate the numericals based on kinetic energy, potential energy, and the change in potential energy, and even we solve the numericals based on the relation between kinetic energy and potential energy. Then finally even we use work energy theorem, W is equal to half mv square minus half mu square. And next session, dear children, we are going to discuss the law of conservation of mechanical energy. So we are going to prove at any point, at any instant, the mechanical energy is going to be a constant. It will be very interesting, and it's very important for examination point of view. Even in a board examination and as well as in a competitive examinations also, it's a very important. Thank you so much. All the very best.